What is the difference between the underlay and the overlay in SD-WAN? If you understand this one concept, SD-WAN becomes much easier to understand. The underlay is the network that actually carries the packets, while the overlay is the logical SD-WAN fabric that's built on top of that network. In this video, we'll explain the difference between the underlay and overlay, why both are important, and why SD-WAN does not replace the physical WAN connectivity underneath it, but it works with it instead. In the previous videos, we introduced SD-WAN and explained what it is. We said that SD-WAN is a modern WAN architecture that uses centralized management, secure overlays, multiple transports, application-aware decisions, segmentation, and policies. But one of the most important ideas in all of SD-WAN is the relationship between the underlay and the overlay. These two terms are used a lot, and if they're not clear, many other SD-WAN concepts become confusing. So let's keep this simple. The underlay is the real network underneath. The overlay is the logical network built on top of that. Let's begin with the underlay. The underlay is the actual transport network that provides connectivity between locations. This could be MPLS, it could be broadband internet, it could be dedicated fiber internet, or 4G or 5G mobile internet. It could be a private WAN service, or it could be a combination of several different transport types. The important point here is that the underlay is the network that provides the real packet delivery. It's the physical or service provider connectivity that allows one site to reach another site, or to reach the internet, or to reach cloud services, or to reach a data center. For example, imagine a branch office with two WAN links. One link connects to an MPLS provider, the other link connects to a broadband internet provider. Those two links are part of the underlay. They are the real connections leaving the branch. They have real bandwidth, they have real latency, they may have jitter, they may experience packet loss, they may become congested, and they may even fail. And SD-WAN depends on them. And this concept, which I've repeated before in this series, is very important. SD-WAN needs good WAN connectivity because it leverages that connectivity that exists underneath. Now let's look at the overlay. The overlay is the logical network that SD-WAN builds on top of the underlay. Instead of treating each WAN connection as an isolated circuit, SD-WAN uses the available underlay connections to create a managed fabric between sites. This overlay may include encrypted tunnels, control information, path selection, segmentation, and policies. But at this stage, the key idea is simple. The overlay gives structure and intelligence to the WAN. So the underlay provides the transport while the overlay provides the SD-WAN fabric. Now, one concept that will make all of this clear, which I wish I was taught when I was learning, is this. The SD-WAN fabric, or the overlay, is constructed between SD-WAN enabled edge devices. Now take a look at this diagram here. At each branch and at HQ, we have an edge device. These are SD-WAN enabled routers that belong to the SD-WAN architecture. They are controlled by SD-WAN. They are instructed to create tunnels between edge devices. So although the underlay is composed of physical devices and links, the overlay is composed of dynamically created tunnels that traverse all of this like a cloud. There is a level of abstraction here that takes place. The overlay says, I want to get to that edge device, and it does so over the established tunnels. But the tunnels are routed over the physical underlay infrastructure based on established policies. So the network at each branch sees the SD-WAN infrastructure like a giant cloud, a black box that links it to every other edge device. How it gets there is up to the intelligence of the SD-WAN infrastructure itself. This is also why SD-WAN is often described as transport independent. Transport independent does not mean transport irrelevant. It does not mean that the underlay no longer matters. It means that SD-WAN can use different types of transport within that cloud network. From the SD-WAN point of view, these can all become possible paths in the overlay fabric, but the quality of those paths still depends on the quality of the underlay. Now, why is this model useful? It's useful because the overlay gives the organization a consistent way to manage the WAN, even when the underlay connections are different. Without SD-WAN, one site may have MPLS, another site may have broadband internet, another site may have cellular backup, and each connection is treated in a completely separate way. With SD-WAN, those different transports can all be brought into one managed fabric. This does not mean that all links are equal. It does not mean that all links should carry the same traffic. It does not mean that all paths have the same quality, but it does mean that the SD-WAN system can see and use multiple types of connectivity in a more coordinated way. Now, before I use the term abstraction, this is a very important concept when we're talking about overlays and underlays. The overlay is an example of an abstraction. It abstracts the complexity of the underlay, making it easier to manage. It's this idea of containing all the complexities of the underlay within a cloud like this. This abstraction ensures that the branches do not need to understand the full internal topology of each transport network in the underlay. The edge routers or the edge devices only need enough reachability to build the SD-WAN overlay between those edge devices. Once the overlay is established, the SD-WAN fabric can treat those sites as part of the same logical WAN. So the overlay creates a logical structure above the underlay, abstracting it completely. Now, this underlay and overlay model is not unique to SD-WAN. You may have seen similar ideas in other technologies as well. For example, GRE tunnels are overlays. IPsec VPNs are overlays. DMVPN is also an overlay architecture. VXLAN is an overlay architecture used in data center networks. In each case, there is a real network underneath, the underlay, and then there's a logical network built on top of that, the overlay. So SD-WAN uses this general idea, but applies it to the WAN in a broader, more policy-driven, centrally managed way. So if you have worked with tunnels before, the overlay concept may already seem familiar. Now, the key takeaways in this video are the following. If you want to understand SD-WAN, always separate the underlay from the overlay. The underlay is what carries the packets. The overlay is how SD-WAN organizes, secures, and controls the WAN. The overlay is built between edge devices and abstracts the transport technologies beneath. In the next video, we will build on this idea and look at SD-WAN architecture. We'll explain the management plane, the control plane, orchestration function, and data plane, and we'll see how these roles work together in an SD-WAN environment. Subscribe to the telecomTech channel so that you can follow the complete series and enable notifications so that you will know when new videos are published. I'm Lazarus at telecomTech, where telecom and networking technologies are simply explained. I hope this has been helpful for you, and I'd like to thank you for watching.